Hello future tech leaders, I am Sindhuja. Based on my own experience, I know that learning the right skills can shape our future. What if I say learning was as thrilled as the tech world itself? There we go. A cloud foundation, that's exactly what you will experience. From day one, you will be immersed in the interactive sessions and expert-led courses that covers most of the widely used technologies in the zone of data science to cloud computing, which brings more light to the life of a techie. I'm so excited to help you and unlock the true potential of a technology. Well, then why to wait? Let's see what it unfolds.
Today my agenda is, let me define agenda of today's session. Start discuss about API design. So we cover the basics of the Mule message processing. Okay, that's two fundamentals we covered. Now I want to discuss about the API design. This is also equally important. Today I will cover the basics of the API design. And we come back to implementation and we see the debug process. How to debug the Mule message processing. And we discuss about MVM component. MVM component in Mule message processing section. These two are related to implementation and we do in any part studio. This we do in the API design. Okay, so this is today's agenda. Now we need to design an API. We need to design the REST API for our integration. So what is the basic usage, basic advantage if I expose my integration as an API? Amut will discuss. Yeah, so the purpose is that other applications can get to, can have access or communicate your application via online. Excellent. So the client or the application which you want to access my API can have a detailed information about my API. So the API design is a simple document. What it tells is, what are all the resources available in an API? And what are all the services my API provides? And for each to access each service, what input the client has to pass. And after execution of that service, what output the API returns back to client. Right. So that information is bundled inside the API so that the client who wants to access the API has a detailed information. What input he has to pass, what output he will get from the API. So all the information he has. Therefore, he can efficiently use our APIs. Right. This acts as a contract between service consumer and service provider. Right, API works as a contract. Right. If there is no contract service, consumer has no way to understand about the service provider. Right. That's right. Okay, now that is the basic definition of the API. Yeah, now coming to the REST API. Let me show you some slides on that. So you know about the REST, right? REST is an architecture style based on web standards. So we use HTTP protocol to implement the REST standard. Right, and REST is a primary basic block. Sorry, resource is a primary basic block in the REST standard. So what is the resource? You heard of resource, Amut. Resource, yeah. In the REST terminology, the resource. In the REST terminology, We always use the resources. Oh. So in the REST, very first step in the REST is we identify the resource. Then you may ask, what is resource? First, they will say that very first step in EST implementation is REST API design is identify the resource. So resource is a real-time object, right? So I want to develop my something like HR API using HR guys. I want to develop some API for HR. So here the real-time object is employee. For this application, employee is an object. What this HR API want to do is it want to create a new employee to the organization. If a new employee joins the organization, you want to create a new employee. And you want to generate the report on the employees for that HR application. Want to retrieve the already existing employees. Retrieve the information about the employees. And you want to change some employee information. Some address got changed. The employee designation got changed. HR application want to update the employee. Update the employee. When employee left the organization, this application want to remove that employee. Delete the employee. Delete, right? Correct? Right. So my API want to do these operations. It want to create the new employees. We want to get the information about the employees. We want to update the employees and delete the employees. So here on what object it is working is it is working on the object called employee object. Right, employee is not a simple string or an integer, right? It is an object. It has some properties. Employee object has properties like employee has a name, employee might has employee number or employee ID. And it has a designation. Some blah 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 properties are there for each employee, right? So this is an object. It is not a simple string, right object. So this is called a resource. I call this as a resource. Resource. The rest are not. So what is resource means? The real-time object that we want to create or we want to retrieve or we want to update or delete. So that object is called resource. Okay. So everything in the REST, it is not about the site. It is revolved about the resources. First, we need to identify the resource. So a resource is accessed via common interface based HTTP standard methods. Okay. So if I want to create a new employee, I need to use some HTTP method to create a new employee. Then what method is appropriate to create a new employee? So to create a new employee, client has to post. Yep, a client who wants to create a new employee, he has to post information about the employee. This is the employee name, employee number. It's a create this employee. That each message comes to the REST API or REST application. And take this employee information and create some of the backend. Maybe store the database, whatever, right, it creates an employee in the backend. So it takes the employee from the client, but that the appropriate method is a post. Post only supports, right? Post has a body. So that in the body this message travels to the application and application can be able to create an employee. For that to create, the appropriate method is a post method, the HTTP standard method. Yeah. Okay, now, sometimes the client wants to see the employee's information. Now the message flows from the API back to the client. This way, right? Yeah. So what kind of request the client needs to do is he needs to do the request using get method. Get method, yeah. Right. Get means get the employee information from the application, right? So to retrieve, the appropriate method is the get method. On the resource, on the employee. If I apply get method, the client will retrieve information from application to the client console. If a client wants to create a new employee, use the post method. In the post method, you post the employee details on the employee resource, so that employee got created on the backend. Right. Yeah, so to update a specific employee, there is some employee called Modi who wants to update the specific employee. The client will pass the employee ID and what information you want to update. Right. Yeah. For that, the appropriate method is the put method. Put method. Yeah. Right. So delete the employee. There is a delete method. These are HTTP standard methods. Right. So on the resource, I will apply this standard method and I will develop the application. That's what here it's mean. I will show you the demo also. Don't worry on that. I really like how you lay it out. So there's a couple of technology here. In the REST API, you deal with the resources. Right, correct? Yeah, exactly. And the resources say that are real-time objects that you want to interact with. Correct. And to do that, you use HTTP method. Either you know to post when you're creating stuff. Exactly, to use a get method when you want to retrieve information. Excellent. When you want to update, you put. When you want to delete, you delete. When you delete the resources or no, you're not deleting resources. So this thing, for example, like say that if you are adding or getting stuff, what is that you're doing? Is it? We cannot say that we are adding resources, right? We cannot say that. We are creating resource on the backend. On the backend. So I thought, for example, in this example, employee is a resource. Exactly. Embedded resource. But what we're adding is that a new employee information or updating information or deleting information. The whole. You know the whole. The root of you know we're not changing that, but we are changing what contains the employee and I don't know table or whatever. Correct. So what is that part that we are updating or deleting or posting or creating? Can we call it a resource or it has a different name? Which one? Which one hammered? So in your example, like the employee right employee, okay. When you want to add new employee, you use a post method. You want to create a new employee. Yes. Create a new employee is a post method. Yeah. And when you want to update, you will use a put. Exactly, retrieve get. So for example, like when we get and delete, maybe get is very straightforward. But when we post in a new employee inside the employee and object, right. Yeah, what I'm thinking about it is that it's like a table called employee, right? Yes, yes, yes. And inside the table there's a columns and rows. Yeah. That shows all the information about the employee. Exactly, so when we add in, we insert a new row. Like a new person. Correct. So, and that's the one we add in or deleting or updating, but we're not touching the employee table. Right? We're not changing the table, but we're changing the rows inside the employee. Yeah, that is on the implementation and hammered. So that is the next phase. We are not, we are still in the design phase itself. I know. So alright. So that's implementation. You can use a backend as database or you can store inside a file. Whatever way you can implement the backend. Right? Okay. So now we focus on the design itself. The design, okay. Alright. I'm getting it. The implementation we do on the Anypoint should be a little later. Oh, got. Right now, we focus on the design. How we are designing this API. There is some one development, some HR API where it's required to create a new employees, to retrieve employees, to update employees, and these are requirements required for the client. We need to do these methods. Okay, how a client can use your API and create a new methods on the backend, new employees on the backend. And how a client can retrieve the employees from the application, how it operates. So all the stuff. But that we will design the API first. Okay, yep, you have to design first. Alright, got it, I'm with you. Yeah, for design purpose. We're discussing about how the API would be designed, what methods used to do what kind of operations. So that's the discussion happening now. I will show you the design, I will show you the RAM, and then you get an idea about how we are designing the API and what is the advantage of design, all the stuff. So, at the time of implementation, your questions will be answered. How we are doing that on the backend, how we are creating databases, how we are creating hosts. That is all the implementation. Right. Now in this session, we will focus on the design phase itself. So the REST application deployed in server provides access to the resources. And the REST client accesses and modifies the resource. Here means REST application. We develop some kind of new application we deploy to server so that it can provide that resource, whatever resource we design. So in this case, employee resource right. So we develop a REST application based on the employee resource and we deploy to servers so that it provides access to the employee resource. And in this case, the REST client is a postman. Using postman, you can access the employee resource and you can modify the employee resource. So that's the reason. By using, get method, get post support. Yeah, get method, get post support. Get post, delete support for each resource. This we'll discuss. And next is okay, we'll discuss about the REML. Now to describe the REST API in the MuleSoft. It uses a language called REML, RESTful API Modeling Language. So to design the REST API, RESTful is R. A stands for API. M stands for modeling. And L stands for language. So RESTful API Modeling Language RML is used to design REST API. Describe the REST APIs. Used to describe REST API. We will see how it is described the REST API. So the MuleSoft designed something called Deliver, something called Anypoint platform. Let us show Anypoint platform. Anypoint platform is a complete infrastructure of the MuleSoft. And using the Anypoint platform, what we can do is we can design APIs. We can design new APIs and we can develop APIs, develop or implement API. And we can deploy our API to different kinds of runtimes or servers. And we can share our APIs to different stakeholders or external clients or internal teams. All those share our APIs. And we can manage our APIs. We can operate different kinds of security policies so that they can secure it. Secure different kinds of other policies also. Then we discuss our policies in that section. We can manage API. So this Anypoint platform provides all these kinds of features. So to design it, we have that design center in the Anypoint platform. I'll show the design center. Now to design API, it is a simple API. Okay, so what is the purpose of the design center? It is a design center. To design it, we have the design center. And to develop API, we used yesterday, right? What is the component used to develop APIs? HEMA. It's the API Anypoint design, right? Anypoint Studio, right? Studio, yesterday you implemented simply an application, right? So where you have all the connectors, all the stuff. So using that we can develop APIs. Anypoint Studio. Studio is a way we can develop APIs and deploy API. We have the runtime. Runtime Manager. I'll show you the Runtime Manager. Locally also, we can deploy APIs using Anypoint Studio. Yesterday, you deployed API and you showed me, right? From the Postman, you deployed API and share API. There is something called Anypoint Exchange. Anypoint Exchange is a place where you can share your APIs. Like, you develop the mobile applications and you put those applications in the Play Store, App Store, so that other guys can be able to download and use, right? Similarly, you can develop the Mule applications so you can post in Anypoint Exchange, so that other parties in the world, they can use your application also. Exchange is a place for sharing your APIs or applications, right? And manage API, something called Anypoint Manager. So there are different components. These are all comprised of Anypoint platform. Platform comprises of design. You can design APIs, develop, deploy, share, manage. To do individual activities, we have separate components, some separate sections of this. So question. So it looks like you know design API and deploy API and share API and manage API. All of that is done inside Anypoint platform. Exactly, yeah. But developing API, you use Anypoint Studio. Yeah, it's also part of Anypoint platform. Is it? Yeah. So the stuff that you have, like where we're designing the Mule events and stuff. That's not Anypoint platform. Which one? The one you would be using, the tool that like Anypoint Studio. This one. So this is not part of the Anypoint platform. No, it is also part of Anypoint. If you go over here, right, Anypoint MuleSoft come. This is where you create your MuleSoft account, right? Oh. If you sign into Anypoint platform, see you land into dashboard of Anypoint platform over here. It's loading. One moment please. It's quite faster. See, this is dashboard of Anypoint platform, right? You can see the design center, you can see the exchange, you can see the Anypoint studio, right? Oh, Anypoint studio there. Anypoint studio, Anypoint exchange, Anypoint design center, and API manager, runtime manager. These are all primary components of Anypoint platform. See. So the first one is where you design API. The second one, exchange, is where you share your APIs. The Anypoint Studio is where you develop, is that right? Correct, correct. So that is the power of Anypoint platform. What MuleSoft do is they bunch all the components in one place and deliver as one single product. And this owned by MuleSoft. Yeah, this owned by MuleSoft. Is it a cloud version of MuleSoft? Is it? MuleSoft is a company, right? So this is a cloud, though this is online. This is a cloud version. Yeah, this is cloud, only this is cloud version. So there is no. I'm not asking we should do it, but that's only an option we have. There is no one we can install locally. Yeah, local installation is also there. Some clients, like banking clients, they don't want to go over the cloud. They won't trust Anypoint. Sorry, MuleSoft, they won't trust anybody. So what do they have then? Then they use the on-prem, the backend systems, and they use some kind of VPC connectivity. To the Anypoint, they can use that. There are several deployment options that are available. MuleSoft ships some kind of product purely on-prem. So they need to deploy the MuleSoft itself completely on-prem. So if that's the case, they will still use the Anypoint platform, but it will point it to their local environment. Yeah, correct. But the design, everything here is the same. Yeah, it's exactly the same. Okay, got it, thank you. Based on the customer requirement, MuleSoft will ship that kind of product. So you have to purchase something from MuleSoft, right, to get that thing set up? Exactly. There are several deployment options available. Based on the customer deployment requirement, they will provide such kind of deployment. You can go for the pure on-prem, pure local or cloud, and there's some kind of hybrid requirement. Some components in the cloud and some components in the local. That is also possible, and you can deploy entirely in the cloud. That is also possible. So different options are available based on the customer requirement. Got it? I'm with you. Thank you. Now, this Anypoint platform comprises all these kinds of components together. So if a customer gets the Anypoint platform, he can design an API over here. He can develop APIs in the Anypoint platform. So the customer can deploy here, okay, and they can exchange. You can put some access management, all the stuff in one product. Now we start the first step with the designing APIs. For that, I need to go to the design center. Start designing. Got it. Now I want to design a very simple API. Now there is already an employee API over here. I want to create some kind of account API. Okay. So some customer API. Some customer I want to create. Some bank wants to create some new customers. Okay, so to create a customer API, I need to log in. After logging, there is a button called Create New. I want you to click on the Create New API. So Create New. Yeah, there are different kinds of options that are available. Right now we focus on the API specification. We discussed the API fragment new application. We will discuss it later. I don't want to miss or discuss all the things one together. The very first step, I want to develop an API specification. API spec. So create new API spec. I need to give the spec name. I'm going to give the spec name as Customer API. Create new API spec. And create new API spec. So if you see over here I need to describe my customer API using the YAML. That is the YAML file. So in the YAML, what is the first activity I need to do? What is the API? Not forget about YAML. What is the first activity? I told you right. If you want to develop any kind of API, what is the very first activity? What do you need to do? First step is you design an API, like a resource. Right. So for me, I want to create new customers. I want to update customers. I want to delete customers. I want to do all these to the customer, right? So my resource is customer. For that slash. Did I answer correctly? Was it say like identify the resource? Yeah, identify resource. The very first step. So I identify my resource as a customer. So I put a customer over here. Now I will develop this API and I will give this API to my clients. Why I am developing this API? I provide this API to the client so the client can use this API, right? That's right. Right. Then client want to create a new customer. Then what method do you use to create a new customer? Post method. You would set the post over here. Right? So that backslash is a comment or is it? Is a RAM. It's a syntax. We need to put for a resource. We need to put slash. This is every resource has to have a backslash. Yes. Or forward slash. Then the resource name. And then colon at the end. It's a resource definition. Now see, I put post over here. What I did. What is the reason I put post over here? Because you want to create something. Now post is a child of the customer. Child means see. You can see some space over here, some tab over here. From here to here. So this indicates that this post is a child of the customer. Means this post is applied on the customer resource. It should not be like this. This is not valid case. So is that like a one-time thing, one tab or two tabs? One. So the method should be child of the resource. Resource, yeah. How you indicate the child means you need to put a tab over here. Then it indicates that okay, this is post is we are applying on the customers. In the same Ravel file, you can have multiple resources. For example, in the Ravel file, I'm creating customers and I'm creating accounts also. For example, So to define accounts, I'm creating one more resource here /accounts. This is a different resource. Right. So in this API spec, there are two resources. One is customer resource is there and account resource is there. Right. And to create a customer, I use a post method. And to retrieve a customer, what method will it use? Get method. So now you see get and post are siblings. They are the same level. Right. To update a customer, what method will it use? Put method. You can even click it. It's clickable. That's nice. It's clickable. Now to retrieve accounts. What's the method? I want to retrieve the accounts. What's the method I need to use? Retrieve. Get here. Get method here. Right. So likewise, we will apply methods on the resources. Yeah. Right. Now we'll go to the second step. The client who is using this resource want to create a new customer. Right? Then use a post method. Then the post method. He will send the customer information in a body section. The body. Right. Post as body. And that body has. And the body might be JSON or XML. Usually we use the JSON or Excel, whatever the content. Now here, if you observe this snippet, these 4 lines, right? Focus on the 4 lines. What are the 4 lines indicates? There is a customer resources there. The resource. HT. Method post means this is used to create a new customer. Yeah, and the client can post the body. Customer information, the body. In what format? The client post in the JSON. And we want to define, you can define some examples also how the customers look like. This is an example. Maybe the customer look like this. Some customer information. Yeah. Yeah. You can put any parameters. Whatever. Right. Now this snippet see. This should be mandatory. See, you should not put all these lines in the same line. See the customer for the resource post the child. For post body is a child and for body, this indication, right application MIME is the child. An example is child of this application JSON. And this type of hierarchical structure means parent, child and relationship. This type of definitely defining things in this manner. This is called the YAML. YAML. Yet another modeling language. So the hierarchical YAML or the language. It is called a language, but it's very simple. Just if you're describing something in a hierarchical manner, that is called YAML. Okay, it's not a language. It's simple. Language means you will confuse a lot. Maybe something different. Nothing is there. Just you defining something in a parent-child relationship over here like this, putting some space in, putting some space here. The space itself indicates that this is the child of this is the parent. So that is called YAML. So can you clarify for me? Yeah, sure. And so Rama versus Yale. Yeah. So Rama versus Yale. Yeah, the language you design in API in MuleSoft called RAML. Correct. But inside the RAML, the hierarchy or structure, how you structure the RAML and API specification is YAL. Yeah, exactly. Your understanding is 100% correct. Oh, got it. So RAML follows the YAML standard. YAML standard means just. I like that. I like how you put it. You say YAML follows. Stands for YAML. Yeah. Another, yeah, it's YAML. It's yet another modeling language, but it's very simple. Nothing is there in the YAML. Just your display describing the data in a hierarchical structure. Okay. That's you're putting some space between child and parent, something like this. I explained right. This is the YAML structure. RAML follows the YAML structure. Right. See, if you see over here the customers in the resource, and then there are different three methods: host method, get method, put method. Let me design a get method also. But get doesn't have body. Actually, get means simply what you want to retrieve information from the client. Sorry, from the server. Yeah. So in that case, I won't send anybody. As a client, I won't send anybody to the service, right? So get as a child is response. Because get expects a response from the server. Right. There are some HTTP codes out there. 200 is a success code and 400 are failure code. Something like that. Assume a success method. First happy path. If it's 200, that response has a body. And that body is a JSON format. Might. It looks like this customers. I see. Some more. It's very strictly. Therefore, we're not following that one. Somebody do something. It's good. So the syntax is complete. It should be. When I put the same level right, it won't accept that. That's right. Oh, now I don't know. This is a simple API. Right? So this API has two methods. One is to create a new customers and other is to retrieve a customer and sometimes write. See the post. create a new customer and get retrieved all the customers in the application. Now you want to see a specific customer. You don't want to see all the customers. I want to see a specific customer for Hamoud from the system, right? Every single customer. For that, I need to pass some unique identification of the Hamoud, like the Hamoud ID or Hamoud name or whatever. Something like that. Yeah. So for that, I need to declare something called sub-resource. Sub-resource, I declare inside the main resource, customer slash and customer ID. Customer. This thing. See customer slash customer ID. Customer ID. I'm wrapping inside curly braces. Right, so it's like a UI. Yeah. Means at runtime, I will pass the customer ID. If you want to know the information about the Ganesh, I will pass the Ganesh ID. I see. If you want to know information about Hamoud, I will pass Hamoud ID. So that one, here I can't. I will apply something called get method to get the information about the Hamoud. JSON. Sometimes it becomes like, so don't worry. Don't worry. Nothing wrong. It gives long spaces but should not be the same level. You can put your example. The example is not mandatory. So all the examples you're using, it's not required, but it's good to have it. Yeah, good to have it. So you're telling the API, this is how the example of the data will look like. I'll show you that one. What is the advantage of putting examples? I can show you now. I can put a simple example. Alright, now it's a very simple API designed for customers. Actually, customers using customer object, right? The real-time data object. I need to declare some objects. In the next session, I will show you how to declare data type. Here I'm putting everything in an example. It's not a standard. We won't use the standard while developing the real-time APIs. But as of a very simple thing, simplify this API definition in the examples. Right? So what happens? Yeah, tell me. Yeah, so you have two methods inside the customers. Yeah, two customers. No, like under customers resource. Yeah, you have two methods. One post and one get, and they're inside the customers. And you have another. So this is also under customer, the customer ID. Yeah, the customer, but it is a resource. I know. But it is inside of a customer's resource. Yeah, correct, inside the customer. Therefore, you see the URL path look like this customer's class. Oh yeah, I see now. Now you want to update some customer. You need to put method over here, not there. Put method. Means you're passing the customer. I want to update this specific customer. Put as the body. I'm not putting an example. This one also. these. There are two methods on the main resource and two methods of resource. Now why MuleSoft advocates design the API? Something called the API first approach. We design the user design for the API first approach. Design first approach. So what happens is actually, when you design the API, in the earlier days, they will develop the API first without any designing. Maybe they implement the API. They develop the API to develop the API. What happens if you got requirements? Requirements that is in the API. Of developing the API, those showcased to the client. They demonstrate to the client. And at this point, what happens is, client has a different kind of expectations on the requirements, but our IT team understands a different manner and they develop the application in a different manner. The moment when you are showcasing to the client got surprised. Nobody, I didn't expect in this manner. I have some different expectations, but you design different thing. I don't want that. I want to know different ways. Right. So at this point, we put a lot of time and effort. So development team put some considerable amount of time and efforts in developing the API. What happens? All our times and effort got wasted. We need to develop again. So instead of that, before developing itself, you design the API. If there is an option to showcase your API at this point itself, the design point itself, right? You showcase to the API to the design point itself, the customer. And you customer give some kind of points. Customer gives feedback. Based on that, you refine the API design again. And you refine the design again multiple times. And at some point of time, you and customer are on the same page. Right. Yeah. So you refine the API multiple times. And that is agreed by the customer. And at that moment, you start the development. After that, once you and your customer are on the same page, then you start the development. So if you follow this kind of approach right, then you can save a lot of time and effort, because at the development point the customer IT team put a lot of time and effort. After that, you want to change something. It is very costly, very expensive. Right before design, it is very less expensive. You can change any time. You can design very easily rather than the development. So, Anypoint use this kind of feature to showcase your design to the customer. That is called a mocking feature. Mock? Yeah, it mock as a developed application. So now I design the API here, right? So you are my customer. I want to showcase this application to a customer. What I'm doing? I'm going to develop a customer API to you. Let me show you this application. This is what you need to send. This is what we will send back to you. Like that. You know I'm mocking configuration. Mocking service configuration. One moment. Do you have to save this? Yeah, sure. Like all this stuff that you did, do you have to save it? Yeah, it's already saved. Automatic save. Automatic save. In the cloud. In the cloud. It gives a copy of the cloud URL. So can you go back one more time? How do you get here? Yeah, this one. If you mock this configuration, right? So you click that we do this one. It gives something link over here. Click that link. Service, yeah, copy settings. Copy URL. Okay, pick and go to the client. Like Postman. And now I want to get the resource to get. What is the resource you are using? Customer. Customer service source. Send it. It will be sent and it returns this one. So I can show you how this is the customer API. So by get method all the customers. So this one is reading the API design. API design, yeah. The customer API design. So how does it know that? So this one. Oh, it's not local right now. We're saying the endpoint. Yeah. We say endpoint. Yeah. And it has that link. It has that program. I can share that with you also. You can also try it out. Okay. I put you in the chart. Oh, I can do that. I can try that. Yeah, you can try it out. One moment, let me grab some water. I'm going to get a little thirsty. Customer send. Was it get? I think it was get. I did. This is weird. Alright. So you create the API. I'm sorry. I'm not there. I just came. I went to get some water. So I was able to. I do the get method and I see. What do you see? That two objects, right? Yes. And for customer name information. Now I want to get some customer name, so I'm going to get some customer. For that, I'm passing something like some XYZ someone to well. Click on that. It doesn't exist. It is going some. It's tooled. Okay, but it's not getting anything. But we have a resource. Alright, let me see the one. So customer really get it. Should have written this example. I'm going to have this thing. I'm going to have customer slash customer. Customer slash customer. I checked it out. We don't have the ID. Any kind of pass anything. It has to return that thing. Because the customer ID at runtime will pass, right? So it matches this thing. It has to return this example, but some way it's not getting it. Customer. Get my time. Sorry, it has a body. It's not a body. It's a response. 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 I was going to say that to you, but then I say it might be different. I noticed this. You had a body. Then I said maybe. Maybe when you retrieve in one person, you need a body. That's nice. Body is only proposed methods. Yeah, you did say that. I'm sorry. No problem. Yeah, that's how you save any moment. Star is not saved. Say automatically for some time, yes. It's written right now. Right. Something of a customer. It takes an ID and it is this one. So this is not an actual working one. This is just marking as an. This mark means as a. Yeah, as we do mark it so that you can demonstrate to your in this payload to a customer. Yeah, this is what you need to pass. This is what you get. So you and your customer write. They get the same page on the payloads, what information the customer is passing and what information, right? So then everything is good. Then we start the development. Yeah, so this is the marking feature, right? And now is it how long? How long does it? And what I've seen, what's the lifetime of this marking? Is it only for temporary? Or is it going to be there for a while? This account, you create an account right in Anypoint platform. The account, you can use a code for 1 month actually, okay? So, but when you have a marking and link like this, how long is it going to be valid? So you see the free account, right? So our free account will valid for 1 month. 1 month, the marking feature will be valid. But yeah, if you have a permanent environment, yeah, that could be until you retire. Right? You'll be able to be available. If you take an enterprise license of any kind of platform, there is an API on the enterprise license you can mark it. That will be available, permanently. But if we develop this API using our temporary accounts, right? So it's for 1 month only. Something like that. Okay? So let me make sure I am connecting all the dots. When you have a requirement to work on a project, you will design this. You will design the API, right? So, for example, I don't know, they will tell you, for example, this is the web service that you need to hit. And this information you need to get from that resources. Then you design the API according to that information. And when you able to retrieve the information is that you want, based on the examples or based on the design you create. Yeah, then you create a temporary link or mark. We call a marking. And you show the customers and say that this is working. This is how you want it. Exactly. So far you using either MuleSoft or the post or something that shows them an XML format or JSON format. Whatever. So the customers you're dealing with, they must know how to use a postman, or they have to use some kind of, that's expected. The customer has to, because this is a CTP application. Right. Yeah, so the customer has if any specific CTP application. Okay, you can test using these applications of a generic clients like the Postman or ARC or something. Some specific client applications are there. So using that we demonstrate to the customer. Yeah. But they need to be familiar with that. They need to know that. Yes, otherwise. Because you know a lot of I don't know. I'm new to this, but a lot of customers they like. For example, was that on the they may have a better QI like a website or something. But here actually the communication between customer IT team and the development team IT team. So usually this kind of discussion happens between IT teams. Alright. Yeah. And I see now, even if I paste the marker, the marking URL in a normal URL, it shows that the XML and output, XML output on the Chrome. You are saying, yeah, I'm using Chrome and I can see now in the Chrome. I didn't say I'm a JSON. JSON. Yeah. The API we designed is very simple one. Yeah. And we discussed a little more about API best practices and design, all the stuff. This is one. So you design the API and you want to implement the API. You want to do some kind of. Here design is simple document. It is nothing. Working copy of the thing. Right? You want to develop some working copy of this API. Yeah, it's just template. Right. Yeah, simple template. Right? So if I can see that. You know, at the beginning you might need to create this, but I can see that the more you do it, you may have a template that you can use too. To configure, to design the API much faster than going tab and picking up all the, do you think that makes sense? Where you may have a template. That's, you can use. That templates we going to develop as part of the API design. The templates is called a resource types and types. Then it in advanced development. Within the meals. Within the Rambler. Within the Rambler. Now this is very simple. We've got very frustration. I like to explain in a very simple manner. I know I explained this one. We can develop templates also. Okay, I think I like the first thing. I like you do, and I like to learn from the foundation and then build on that. Exactly. Okay. Now I'm going to my new points to me over here. My intent is I want to do some working copy of the customer API. So I'm getting new project. As a customer. That location. Somewhere I do. All the existing different customer API. I am here one. The rambling that is in the right download RAM. This is the staff. I need to do my credentials. On this one location. Ask me any kind of questions. Show up all the API is present in my business. Okay, so I want to create implementation to the customer API. So I'm setting this one API. Okay. So it will create a project that implements the customer API, which is see, I create a project called customer API. I am here one. And if you see this project, you have this project right. There are. This is called main flow. This is called router flow, main flow. This is called a pick it up. I will explain what is a pick it out. If you see the API you designed, how many resources are there? There's only one resource, a customer resource. And the customer resource. How many methods are there? 2 minutes. 2 is it? Is there one more? Yeah, 2. And the other one was ID. One more sub-resource are there. On that we have one method. One method to 2 minutes. 2 minutes. So, as far as the API, you need to provide implementation for the 4 methods. One method is to create an API. So, it's time to create a customer. And second method to get to the customer from the back end. And to get a specific customer and to operate a specific customer. There are 4 implementations. So, if you see the Anypoint to your project you created, project to be created. See, there is one flow over here. And flow number 2. Flow number 3. And flow number 4. The 4 flows are here. Oh, so each method. Yeah, exactly. Each method has a flow, And each method has a flow. From the postman. I want to retrieve a customer. Post from the postman. I want to create a new customer. Postman, I call it a client. Anypoint. Design center. This is the sequence design. Let's see. Post customer. The flow path. I call it a method. Right. So what happens is from the customer, from the postman, there's a post method. And you send some customer information. I use a post method. and you send me some customer information, the body. The corresponding the implementation lies over here, actually in the new flow. Here you write what happens, what to do when post method. You know you want to store into the packet. You create something database component over here. Okay. And that will store to the backend. Database and table will be there over here. Customer table. Customer. If you add, say, takes this customer and adds a record over here. That's a portion of the right. So once again, I'm sure I understand. So the client post a message using like a Raman specification. Yes. And then the Rommel passes the information to the Mule and REST API. You know. I don't know. So this was a Rommel. And now it become a Mule event. It's not like that. This Mule flow is created based on the Rommel. Oh, seems a little confusing. I put Rommel over there, but this snippet created based on the Rommel. So it won't call this one. And this one will call this. That is not the manner. This is a design part. And for this design, this is the implementation part. But in the runtime, client will call directly the implementation part. The design is not in the picture. This arrow is not at all valid. I'm sorry for confusing you. Just I want to explain something like manager is not working. Okay. That's okay. So client will directly call the implementation. But this implementation is created on the base of this design. That's what I want to say. That's right. So it is now. It is a dummy implementation, but we need to create an implementation. Now, actually it creates a dummy implementation. Yeah. So the project is created on some dummy implementation. But as we are developers, we need to put actual implementation over here. So what do you want to do when posting in the post? We want to save the information to the file system. So from here. So Ganesh from here. This is the post method. Yeah, one on the top of it is a good method. And the other sub-programs or like ID stuff. Yeah. So if what I'm doing is now, I'm simply a defense application. So I'm not at all implementing anything, but I'm deploying application. Simply designer idnic. X time for the intro. So if I deploy this application, it's facing face. The next phase is starting phase. Now deployed. In that case, I need to put localhost over here because I should not over invoking the marking guard. I'm using get, I guess. 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 So right here then. Which one is the main flow, or this is the main flex for this one is A. You know every request will come. So you know there's only one resource here, right? Oh, one is there. I did that first, but there are no list of configure. The source is empty. Request lines over here. Okay from the postman. What did localhost A to refund/API write? See, if you see this laser path is API and localhost 8 it was. So the request comes and lands at this point, then go to router. Yeah, router, but yeah, I was gonna say, I think you get into that. But there are more other stuff in this page than the 4. Yeah, like those ones, I'm not sure what it is. Yeah, this one we will explain later. Okay, that's fine. We discussed about error handling. That moment I will tell you what is on. Error propagate on the stuff. Don't worry on that, you just understand it. Now try to understand how Rata routes the request to a specific flow. Okay, so if my request is like this, the method is get and the resource is customers. Okay, so localhost 8081 Nepal. This is the URL the listener receives. Actually, is it localhost 8081 API? Right. Okay, afterwards, what URL I'm requesting? Customers, I'm requesting. The method is get. So it routes to the flow that is matching customer and gets over here for that. This is the method, this is the flow, that is a get method and customers. Right? So control comes over here. Therefore here, okay, this is going to be whatever you defined. Over that's come back to our client. I'm sure that's it. Is it complicated? Hammer. Now now I understand. So alright, the first one is gonna route to. If I put like this one over here and this one point to this flow. Yeah, because postman we asked to get it. We didn't say to post it. We didn't say to put it right. We say get. Yeah. Because it's gonna route you to the get method. Exactly if I put the post. It's gonna take you to the post. Post method, right? Yeah, got it. This one will invoke this call, will invoke this flow. Post like this. Flow that waiting to invoke the post method for this flow. Yeah. You put some loggers and then also you can test is control coming over here or not. So call will land at this flow. So now the client is customer. This can send a body the customer information and we can create the customer on the back end, right? The application can take the customer information and put it on the back end. You can modify it. You can do all the operations I can do right as a customer. Got the employment of importance of this API. This is a very basic thing. We're going forward. We're going to discuss a little bit advanced concept of API design. Hope this has got some idea about the API, the best API resource. Yeah, this is really good. It's really good because like we designed the API. We test it, we mark it, then we implement it. Yeah, implement it. And then you can retrieve it in a Mule. Like in a Mule. What do you call that? Studio or something? Endpoint Studio. Then you import. Yeah. We need to deploy you import in an Endpoint Studio where you can do more like a transformation or more parsing. I don't know. So at the end of the day, is that when you download it or move it to the other Endpoint Studio. You will do something with the message and then either it's stored somewhere or do something, whatever that customer wants. Correct? So that's like high level process, right? Exactly how API design or API through MuleSoft works. Exactly. Now we send this thing, right? So now what happens is the request go to the Mule. And it takes a Mule request and transforms to HTTP request and transform Mule. That will all that happens over there. That's the story we discussed yesterday. This is a basic fundamental on API design and API implementation. That's nice. So now coming to this is a debug process. So debug process is very important thing while developing. So what I want to do is I want to put some logger in the post method. I want to put one more logger. So in the logger I am putting a sorry. If this concludes post method. I'm putting you, apply it. I'm putting some traces. So I want to debug my application. You know debugging, right? Debugging means you want to walk through the application flow, how your application executing. Some of you got an error. Debug is very important to trace the error at what point the application is erroring out so that you want to identify right for the purpose with the debug. Got it? So the debug we need to put something like breakpoint means at what point you want to, from what point onwards you want to walk through your application. That is your breakpoint. So here what I am doing is I am creating one more variable over here. I simply put a variable some logger, not a variable. I am putting some logger. Some static test in the customer API. So I am putting a breakpoint over here. The breakpoint is right. Click over any component and add breakpoint. Add some dot in the corner. Now I am starting my new application in debug mode. So who currently is running on the run mode? Stop it and right click here at debug project. Select the debug so the project will deploy in debug mode. So now I am hitting my request. So if I hit right, what happens? The control is stuck over here at this point. See. You see, this one got highlighted right. So you can see at this point what is the payload, what are the variables, what are the attributes, all things you can see at this point. So at this variables matches with that. So let me come down. So now payload. We are not seeing any payload. The payload is empty because the body is empty. Actually, we are not seeing anything, so body is empty. Therefore, the payload is empty. You could have seen some. Variables are also zoo. There are no variables stated. Now see the attributes in the headers. Are you sending the attributes? Let me see. Are you sending the attributes in the Postman? There are no headers you are sending, right? There are no query parameters you are sending, so attributes are also empty because we are not sending anything. If you send, I can show you that one. I will share down this thing. Let me do one thing. Let me send some information. So I am sending some header parameters. I am sending query parameters. I am sending body. So posting this thing now at this moment. Let us see. The payload is name Mary. This is the payload you are sending. What are the attributes you are sending? You see the headers. Technology is going to be so. This is one header. We are sending the query parameters. On query parameters, we are sending. That is called city is equal to New York. We can see. Now I am moving a little further. If you press F6 or you can press this one next processor, it comes over here. Press F6 again, see the control. Go to the post method, post customers. How it goes to post customer? Because we are using post method and the resource is customers. Therefore, it goes over here. And if you press F6 again, goes to variable and press F6 again. See now a new variable got created. If variable size is 2, now see employee name is equal to Mary. What is this? I do not know, but employee. This is one employee we created right just now. Now F6 means the flow got executed, completed, and you can see the result in the post method. If I use a get method, now what happens? See, send it. It come over here. Come over here. Now put F6, the control goes to get customers. See. Get customers. The flow is because the request is on the customer objects. We are invoking get method. The corresponding flow got invoked. This will get executed. This got this information. How more this information? So after execution of this one in the client, you can see that got it. So the school management API. The requirement is like this. Let me share the requirement. What's the requirement? We will see. So every year a new student will join the school, right? New batch of students will join the school, right? So you need to register the new school. New means the API, the application you're going to develop. That needs to register. Using VM component, we do internal messaging between Mule applications. It is called a virtual machine component. It stands for, but in simple terms, it is a messaging system between Mule applications. It is a virtual machine component. It is a virtual machine. 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 So usually it is a JMS queue that is called ActiveMQ or RabbitMQ. Some implementations are there in the JMS queue. It is ActiveMQ and I can share the RabbitMQ also. How to use RabbitMQ? That is an implementation JMS we can use in between multiple. Different kinds of applications, heterogeneous applications, like maybe one application is running on a Python or Java or any other technology. So this application want to send a message to Mule application. So it will send a message to the JMS queue and Mule application can listen that message from the JMS queue. Mule application can able to listen that message from JMS queue and process that message. So JMS is for multiple kinds of applications. Even we can put JMS between Mule applications also. It is not there, but JMS, we can use different kinds of applications. Can you know? JMS work as a broker between different kinds of applications. Where the VM component is purely between Mule applications only. VM is purely between Mule applications. And other thing is Mule applications run in a runtime server or runtime. Suppose this is Mule runtime, where we deploy all the Mule applications inside this runtime. This is Mule application. One Mule runtime with a server. Mule runtime with server where we deploy Mule applications. Even if we are executing the Mule applications in Anypoint Studio, right? Anypoint Studio is embedded with the Mule runtime Mule server. Anypoint Studio is embedded with the runtime. So that we can deploy our Mule applications. That runtime is called embedded runtime. Embedded runtime at Anypoint Studio. So embedded runtime is only for testing the applications. It is not for production grade server. Whatever application you develop in Anypoint Studio, that application you test inside this runtime. But Mule provides you the runtime on prem runtime. You can download it and you can deploy. You can deploy applications on that runtime. You are going for production, then you take license. But for learning purpose, you can download the server and you can use it. So where we are? We are actually between COOS and JVM. COOS JVM component is the communication channel between the Mule applications that is running on the same runtime. So in this runtime, two applications got deployed and and I want to establish a communication between this app1 and app2 to VM component. App1 can send a message to the VM, and app2 can take out that message from the VM. So VM components are the broker between app1 and app2. VM is one of the components. Is not a Mule runtime. Mule runtime is a place where we deploy Mule application server. Actually, this entire Mule is a Java application. Now, first of all, very first thing, why we need messaging is there. Any application is there, app1. And when app1 wants to send a message to app2, it can send directly a message to app2, right? Then why we need to put a broker in between? You want your application to be more reliable. We are not sure our application will be running all the time. Maybe application is down for some time for some reasons. For example, app2 is down. It is not responding, so app1 keeps on sending messages to app2. Not aware of, it is running right, so we will lose the messages. Instead of that, if app1 will send messages to some queue, messages will be stored inside the queue. Whenever app2 is up, it will take the message and process the messages. In Mule, if you want to put this kind of queue between two Mule applications and app2 running inside the runtime where the Mule applications are running, that is called a VM. There is one thing to publish a message. To publish a message from application to VM, there is one component that publishes a message. To receive a message from VM, there is one component that is VM listener is there. We will discuss about VM components. What are the different components available? Now we are discussing about the concept called message channel. What is the difference between the VM component and the JMS component? Both are look same. Both functionality, the purpose is same. It looks a little confusing between the VM component and JMS component. That you need to understand the difference between where we need to use VM and where we need to use JMS. So JMS, go of JMS. JMS is a different server. Okay. For example, if you take RabbitMQ, we need to download the RabbitMQ and we need to start the RabbitMQ server. So inside RabbitMQ server, we need to create queues. Every queue has a name, but suppose you create a queue called Q1. And what we do is, there is some application is running on NetT. So this guy will send a message to the Q1. And our application can listen that message. And pass that message. You will be sending on. This application is running on the runtime. Okay. So RabbitMQ server is not part of the new runtime. That's right. Right, this new server is different. This new application is running. And NetT application is running on some NET server, some ISS server or something. NET server. A separate server. So a client has a separate server. A Mule application has a separate server. RabbitMQ has a separate server. So this may be sitting on a different machine or maybe a different geographical location. And our Mule application is sitting on a different location. Maybe geographically they are apart. Right. So if you have such a requirement, then we go for JMS. We are establishing communication between different platforms. This is a neat platform. It is a Mule platform. Different technologies, wow. They can talk to each other using the JMS. Metagenesis technologies, whereas come from Mule. Sorry, VM component. VM component. Actually, there is something called JVM. Java extension. Where all Java applications are running. Mule runtime is also one of the Java applications. So Mule's runtime or Mule server runs inside the JVM. And inside the Mule applications we deploy. Sorry Mule server, we deploy Mule applications. This is M1, M2. Mule application 1 and Mule application 2. Mule server hosts the Mule applications. Java which hosts the Mule server. And maybe some VM component also as part of the Java virtual machine. Right. Mule application will send a message to the single component. And M2, the server Mule application 2 can take a message from the VM component. So this is local to the Java virtual machine. So this is little fast compared to JMS. VM is fast because it's local, right? It's not crossing the boundaries of your machine. Everything is running on the same machine. Look, M is fast. When your requirement is very simply, you need to establish communication between the Mule to Mule or inside the flow to flow. We go for the Mule. Okay, that improves performance of the application. Right? When two Mule applications are running, one Mule application is running on one Mule server. Another Mule application is running on other Mule server, a different Mule server. Mule applications are running different Mule server. Then if you want to establish a communication between these two applications, then we need to go for the JMSS kind of server. JMS, because they are not running on the same application, right? Same server. So where we need to go for VM1. If they are running on the same server, the application is running on the same server, we go for the VM. The applications running on different machines, we go for the JMS. There is one exception. I can tell you that one. When we deploy the application to the cloud, I will tell you that one. As of now, just focus on this one. I can tell you the VA. Once we discuss this one at deployment, I will tell you that one. How it behaves on the cloud. JMS is actually a spec. Spec means it talks about how do you know how a Java application talk to the machine system. to messaging server. This is the only spec where there is no implementation defined in this spec. Only a specification. Just it talks about how your Java applications can send a message, can consume a message, can listen to a message. All the things are defined. Only simple rules and regulations are defined. There is no implementation. So the companies like RabbitQ take this spec and develop the messaging server based on the JMS server. Now, this is the actual implementation part. People can put a message over here, can listen to a message over there. And companies like RabbitQ, so many companies have their Appium queue. This is also based on JMS spec only. Take the JMS spec and develop the server. JF. So different servers are there, all based on the JMS only. But these are actual runtimes, actual servers where they host the messages. They are all based on JMS only. You take the JMS spec and develop the server. JVSMQ can develop this standard. JVQ is a standard. JVSMQ is a simple standard which is not an implementation. Where is the Appium queue? JVSMQ. These are all based on the JVSMQ. They are developed based on the JVSMQ. With the help of JVSMQ, we can send a message to these servers. These servers may be running different port numbers. If you configure that one, it will go to that server. VM is not a full-fledged messaging system. It provides very simple messaging. Just put a simple message to push a message to this queue and consumption of messages. Simple, something like that, but you can't get acknowledgement, all that stuff. VM is a very simple messaging system. It doesn't have advanced messaging features. And if your application needs advanced messaging features, you need to go for JVM. Sorry. So let me create one simple application. See runtime. For the runtime, we use Server Photon. Embedded insights in the Point Studio. That's right. My project is simple. So what I'm doing is I'm just publishing a message to the VM queue. So I'm configuring a listener. So HTTP client, I just get a message from HTTP client, and whatever message I got from the HTTP client, I will push that message to the VM. So I'm configuring the HTTP message. Is okay. The default configuration is fine. Path has been given, we can send something. You search for VM on the component palette. You find 4 components: consume component, listen component, publish component, and publish consume component. Right. So to publish a message, we use the publish component. So if I put a publish component over here, What this component will do is it publishes a message to the VM queue. So I'm configuring the publish component over here. Connector configuration. It tells about how Mule application is connecting to the VM queue. You need to give the queue names. What I'm doing is, I'm just creating a queue name. And I need to tell the queue name to which queue we need to post the message. I'm just creating a queue name. I'm giving it as something in the name I can give VM1. And here, the transient tells about transient. By default, it is transient. For example, when the server is when this application is executing. Some reason the server crashes or we lose that message. Oh, it's the same configuration. If you put this queue as persistent, what happens is it stores the message to some external storage like a file system. So even the server crashes, we can the call messages will be remain in the file system. We can restore the messages. That's the configuration of transient and persistent. So we can tell how many messages to host. That is about a max of sending messages. 0 means it can host a number of messages. There is no limit for that. So that is another queue configuration. Queue name is VM1. So now, this is the only connector configuration. We just created a VM queue over here. Alright. And next thing is what content we're going to post to the VM queue. So now I'm posting the payload. Or else, if you want to post some variables, you need to change them to the variable name. So that variable content will post to the queue. This correlation ID. We will discuss what is the important part of correlation, how the messages got correlated. I will tell you this one first. We go for simple thing. We will just go for complicated thing. Next thing is a queue name to which queue you want to publish. Right. So I want to publish to the queue called VM1. That is what I created in the connector configuration. Queue name is VM1. So in the connector configuration, you can create multiple queues. For example, I'm creating one more queue as a VM2. Yeah, I'm making this as a persistent configuration. So there are two queues I created, right? One is VM1 and VM2. While sending the message, we need to tell out of VM1 and VM2. Which queue we want to send? You can choose either VM1 or VM2. I want to send to VM1. Now what happens? To publish like this. This publish component publish the message to the VM queue. That's it. It is a one-way only. Okay, so it won't expect any response from the VM server. If you put logger after this, what happens? I'm just publishing the building of payload. Payload of the I'm getting the payload. Let's observe. I'm trying the application. So meanwhile, I can tell you one thing. Here you can see the 3 tabs, right? Message flow, global elements and configuration XML. 3 tabs, right? Message flow section. This is the graphical view of your new application. So graphically, you see that this is not published component and logger. And if you see the configuration XML, this is a source code view. The same application. If you do anything over here, add a new component or delete a new component, that's what you will get over here. Okay. So now, as part of your Mule, configuration Mule applications. There are some configurations we use in multiple flows. This is one flow, right? You may have one. This Excel can have multiple flows. This is flow 1. And you can drag one more flow. This is flow 2, right? Flow 1 and flow 2, you have multiple flows. If your configuration used in multiple flows, the same configuration, what we can do is we can make it as a global configuration. And that global configuration is referred in multiple flows. What I'm doing is here, I'm creating one more flow. I'm referring this one. That is part of C, only part I changed. See, if you see, this is called VM send and this is VM receive. And counter configuration, see the counter configuration is HTTP, lizard config. And here also the counter configuration is HTTP, lizard config. They're both referring to the same counter configuration. Right. I'm putting some logger over here, simply one logger, and these both flows are referring to the same configuration, same lizard configuration. Right. So that is a global element. See, global HTTP lizard config is a global element. And that global element are referred in multiple flows. In sense to one thing. Come to configuration XML. Right. See here. In the configuration XML, there is a tab called flow. It's a flow starting. And this is called flow ending / flow ending. This segment, right? This segment represents a flow. This is one flow and there is one more flow starts with. The two flows are there inside. Okay. So if you see, this is flow 1, this is flow 2, right? The same thing. So the configuration inside the flow starting and flow ending, that is called flow local configuration. So this is called flow local, inside the flow, simple flow, right? This is also local to this flow. But if the configuration is above all the flows and it is not inside a flow, see, this is not inside, not enclosed in any flow. And this configuration is also not enclosed in any flow. These two configurations are called global configurations. Okay, they're not local to any flow, right? And there is some component called HTTP listener. It's referring configuration ref, referring to something called HTTP listener config, right? This HTTP listener config is defined over here. HTTP listener config. So what this listener component is doing, it is referring the global configuration. See, the name matches over there. Ref and the name should match. These two are matching means this is referring this global configuration. What is the global configuration? The host is a local host and port is 8881. And the second flow also. The second flow also the HTTP listener attack. That is also referring to HTTP global configuration, HTTP listener configuration, this one. Right. Means both flows. Both the listeners are pointing to the same host and same port. And what is the difference? Is this is defined second a path called VM, receive the second listener. This is VM send. Okay, this should be different. If you don't, if it is also the same, you'll get error. See, this is also global configuration. VM config is global configuration. It's not enclosed in any queue, any flow. This configuration is referred while publishing the message. Right, see? VM publish is a component that publishing the message to the queue VM :publish. And there I can expand this one. VM publish queue name is VM1. This publishing VM1 queue. And reference here. Host stack format. Yeah, VM publish. Configuration is VM config. So where the VM config is defined, that is different as a global configuration. Even the second flow, what I can do is I can consume the message. In the first flow, I publish the message right. In the second flow, what I do in the second flow is I consume the message. For that, I am going to the VM. Consume the message. But consume the message, also I can refer to the same VM configuration. Publishing. Also I am configuring the same VM config. Consume the same VM config. I want to listen from a queue called VM. I publish to the VM1 queue. I publish to VM1 queue, consuming from the VM1 queue. Right. What is the basic difference between synchronous and asynchronous? Any kind of an application I make a client. I send a request to this application. The same request, the same thread. I expect the response. So maybe I wait for 30 seconds or something like that and the same request. Request is sent and I will expect the response. If I don't get the response, the client will time out. Timeout error. Yeah. So this is called synchronous call. Oh, right. So the client expects the response immediately on the same call. It won't wait for a long time. Whereas asynchronous work like this asynchronous. Client. Send them this request. And what is asynchronous? Where we do for asynchronous, there is on this request. It requires some approvals. For example, you are applying for a loan. And loan. They won't approve you at that moment. They do some background checks and some credit checks. And after that, they will respond back to, okay, your loan is sanctioned, something like that. Okay. So for that, for long running process, we use the async system. For async system, what the client will do is along with the request, he will send the callback URL. Call URL. Yeah, along with the request. He will send callback URL and tell that server, hey server, once you complete your process, send your response to the callback port. And it will send the response to the callback port. Then the client will pick up that response to callback port. That is not happening in the single call. One call is for request. And the server gets the callback URL. After processing, the response will send to the callback URL. Okay, now these are two different calls. One call is for request and one call is response. This is asynchronous call. It's on timeout, asynchronous. It won't expect the response immediately also. So it won't wait for response from the server. Just send the message, that's it. One way only one way. It is one way. And this is one way. One way response, one way request and one way response. Whereas it is two way. Synchronous is always two way. Two way means request and response on one call. Request response messaging pattern. These are all called messaging patterns. In a synchronous call, it won't wait for response. There are two types of asynchronous calls out there. One thing is as a client. I'm calling the server application. So I'm just sending a request. I won't wait for response. And just send a request. And I can do other activities also after this one. For example, there is something called send a request to some queue. And next print that request to the file. And do some database call. Something like this is there. So what I can do? I can send a message to the system and continue my work with other components. I don't wait for the response. I want to block over here. Whereas in asynchronous call, I block over here. Until I get the response from the server, I can't move forward. Once I get response, only I can move forward. That is called synchronous system. Synchronous means it blocks. It blocks until you get the response from the server. It blocks here itself. Whereas asynchronous, it just sends a message to that server and keep moving and executing. Next components. Now sometimes we get doubt, we send a request. How we can get the response back and where we can collect that response. So, like I said, there are two ways to collect the response. One way is no, it is not related to Mule. It's a general concept actually. Assume this is the client. This is server. The client sends a message. The client also expecting a message but not immediately. It knows this is a long duration call. Server will take some time. After some time, the client will expect the response of this message, the request of response of the request. There are two ways we can do asynchronous call. One is polling manner, polling way. Polling way is something like there is some agreement between client and server. So once the server processing this request, it will put in one place. Server take the request and process the request. After processing, it will put the response in a place. So the client keep on checking this place. Is the response arrival? Is the response arrival? Is the response arrival? Some scheduler call it. Scheduler keep on checking this place but need response. If the response is available, we fix that response and process that. This is called polling manner, polling way. And second is the callback. In callback way, client won't poll, won't check for response. While sending the request itself, it gives some path. Hey server, once you finish your processing, please send the response back to this path. The path is given in the request itself. So server process that request, and once you finish the processing, the response is sent back to the path the client has given. The client pick the response. So these two are the asynchronous ways of implementing the system. Okay, this is a bit preferable manner compared to polling. A callback is preferable because client need not check every time, right? Once you are processing, you get the response from the callback port. Okay. But see, this is one way and client also server sending to client in different calls. This is two-way call, right? Two different calls. Yeah, not in single call. Single call means single call that is synchronous. What's the important, takeaway in the today's session is about the source code. Most of time we work on the graphical mode. Yeah. It is equally important to have idea on the source code, how the source code is getting generated. You add a new component or you delete a new component. What is a global configuration? What is a local configuration? That idea is very important. I'm running this application. I demonstrate and compute. Oh. There is some 8 or 81 complete in my machine. So I change it to 885. /VM. I'm sending some content. This is the content I'm sending. This message I'm sending to the VM. Post it. And yeah, we send that message to the VM. And next, I want to get that message from the VM. This will be and what is the path to get that? It is a flow that is fetching the message from the VM, right? Yeah. Get. I'm spilling this. I push to the VM and other from the VM. Okay. So this is what I did is from the postman. This is called VM send write. It's a send it, send and post to the message. Publish. Somewhere VM is there. What VM? The true name is VM1. So this will publish the message to the VM1. And it only one way, just put the message and expand and exclude the logger. Okay, logger, I'm printing the payload, whatever a post message I printed. I posted that, but it's already in the logger. I can show you the logger also. Right. And message is there in the VM log. So from the postman, again, I'm invoking this listener using VM receive. That's VM receive. That control comes to this listener. So this will go to consume. It calls the consume component. Consume will go and fix this listener, this message. And use that message back to listener, and listener will go back and send to postman. And that message got printed over in the postman console. So VM is used for messaging as a messaging broker between new applications and simple messaging broker, right? The 4 operations in the VM component publish. One publish to consume and listener. And fourth one is publish, consume. The 4 operations. Just you need to know and practice once. That is enough. And in last session, we discussed about publish and consume. So these are both one-way operations. One way means if you develop a flow and you configure a component called publish. So what publish will do is publish. We'll publish a message to the VM queue. In the VM queue, there is a queue. Is there a name, any name to this? You can give name to this. So it will publish a message to this queue and move ahead processing the next message. Next process, move ahead and next process will process that message, but it will not expect any response from the VM. Just publish one way and execute the next process. But in the VM, if you define any queue, if you name any queue VM1 or any queue, in the last example I given name as a VM1. It is internally, it has 2 channels. Every queue has 2 channels. One is a primary channel and second is a replay channel. So primary and what is other one? Replay channel. Replay queue. It is primary queue and replay queue. Okay. So each queue has that 2 channels. Exactly. Each queue has 2 channels. One is for taking the input and one is the giving the output. Like that you can remember like that input and output. Publish always places in the input. It will not expect any response from the output queue. Just put the message over here and move forward to the next process. whereas a consume also. To configure a consume, and if you configure to a queue, take the message from the queue like you configure a VM1. What happens is go to the primary channel and take some message and go to the next process. Right, so these two. This is also one way. This is, publishing the message to the channel, and this is consuming the message to the channel. That's it. Vera has the next two components. These two components, listener and publish. These are two-way components. It's not listener and publish, consume. These two components are two-way components. Okay, let me give you one small example and I can show you the Anypoint to be okay. I configure a flow. And as part of the processing, I configure a component. This is called VM publish consume. Pub and consume. I'm leaving this pub and consume. This is VM publish consume component. Okay, so what it will do is it will publish a message to the VM queue. To the primary channel. Some people call as a main channel, main queue. Every channel, it will publish some message. It will expect the response from the reflect channel. There are a few components. You can't figure out part of the flow. The control won't move further until it has a response from the reflection. It puts a message in the primary channel and waiting for response on the reflect channel. It's blocked for some time. Oh, this is one way and it's waiting for the service. And there is one more component, a listener. So far, all the three components we discussed are event processes. What are publish, publish, consume. These three components are event processes. They do processing on that event. Whereas the one component in the VM stack that is called listener, that is event source. Listener, VM listener. Listener by definition, what is meant by listening? It's keep on listening for a messages. That guy is called listener. Okay. We have HTTP listener. What HTTP listener will do? ATP listener. Keep on listening for a messages. HTTP listener in your examples. As part of HTTP listener, we configure one port. We can configure. So there is one port in your machine, either in your system. The listener always checking for messages in 8081. Just keep on checking every 1 second, 2 seconds. There is some time configured internally. Every second, just keep on checking. From your postman, if you give localhost 8281, postman will put a message in 8281 port. So your listener will take out that message and process it. Right. So the fundamental is listener is a guy is always, checking on a port or on a place. Also, in VM, listener will tell where it has to listen. Okay, I tell that the VM please listen on the VM1 queue. So just keep on listening for messages on the VM1 queue. When you find a message in VM1 queue, it takes a message and it processes that message. After processing finishes, puts the message back to VM, but it puts in a replay queue, not in the main queue. Take the message from primary queue, process the message, and after processing it, places the message in the replay queue. Right. That's the VM listener. VM listener. So it listens where? Where does it listen? It listens in the queue or listen is in, I don't know. Like I don't know what. What does it listen at the beginning? Listener listens on the queue. Primary channel. So it checks. It checks the primary channels all the time. So your example like HTTP listener. Is that what you're talking about? Yes, I give an example. HTTP listener. Always listen on the port. You can't pick up. Where the VM listener, it listens the main queue of the VM. Exactly correct. And the main queue of the VM is not an. It's something that you have to define first, right? Yes, define first. The system MuleSoft or the studio we have, it doesn't create one by itself. It doesn't exist unless you create, right? The VM listener. The queue I mean. Queue as part of the VM configuration, we need to create a queue first. Okay, once you create, then you can let VM listener listen to queue. Exactly. And then it checks every time. If there are message in the queue, and then if you bring it in and inside the flow to process those message. Exactly. It will then process it and it puts back the answer into the reply queue exactly. Excellent. Now I understand. Thank you. Very good. Wonderful. So now this guy, right? The first guy I told, this publish consume component guy. So this guy places the message in the primary queue and waiting for the message on the reply queue. Right. Yeah, so once the listener finishes and places that message in the reply queue, it picks up message. Then it moves further from this component to this component. So these two should be configured as a as a batch, because if you configure only publish consume and you don't configure listener mix, your publish consume will time out. So you have to have VM listener. Then after that you have a publish consume. Yeah. So first you can define in any manner. Order is not important, but these two has to be fine in your application. Okay, because these two are two-way components, because the publish consume is placing the message in the primary queue and expecting the response on the reply queue. Right. Until it gets response on the reply queue, it won't move further. It's blocked here itself. whereas listener is taking the message from the primary queue and after processing it is replying on the reply queue. Right. Oh, so somebody, another, I don't know, another thing, another channel has to pick it up from the reply and do something with the events or the message. Yeah. This guy reads the process, the message and put in the reply and then either publish consume or consume can write. Can go there and pick it up. Consume can access only the main queue. It takes the message from the main queue only. Consume only access to the main. That is one different. How about the publish? Publish also plays in the main queue. So the only other channel that we can use is the public consume. Exactly. After the VM listen. Got it? People has, one doubt. Always my student ask. The doubt is see both consume and listener. Both are consuming the messages from the VM. Okay, then what's the difference between consume and listener? Consumer. Consume also consuming the message from the queue. VM also consuming the message from the queue. Listen also consuming message from the queue. Then what is the difference between consuming using consume component and consuming using listen component? Yes. I think the way you explained to me was that the consume can only consumes message from the main channel or main queue. Okay, that's it. Where the listener, it can also do it can also get the information from listens, the main queue, but it puts the message into reply queue. Yeah, that's true. But in terms of consuming the message. In terms of consuming the message. So the primary difference is, but consume, see. One consumes the queue, right? And the other one listens. Let me put the listener over here. This is your listener. So you got stopped. Okay. So anyone in queue called VM1. So here also consuming from the consuming message from the VM1 queue. Okay. And these are also listening messages on the. Yeah. So the primary difference is in the behavior. They are consuming the message. If you observe the consume, somebody triggers this listener from the postman, it gets the invoked. Then it will call consume. Then consume will go and pick up the message. Okay, if somebody not call this listener, consume will sit idly. Won't go and pick the message until it gets the invocation. Okay? Then only it's going to pick the message. Oh, so it doesn't listen. It just consumes the message. Consumes the message. Whereas the listener, nobody need to involve this one. Just keep on listening on the queue. Is message there? Is message there? Is message there? If message is available, then pick the message immediately. That's right. Do you know the name? Actually, the name says everything, right? Yes, when listen is the queue and the other one consumes that. Somebody will tell to consume. Hey, consume, go and pick up the message. Then it will go and pick the message. Or else it sits idly. Got. So that is the problem. I don't know. I don't know why we make you know. It's very simple the way that they define it or instruct it, but somehow I don't know. And we think it's more than you know. We're thinking it's more than what the name. You know what the name says, but it's okay. So you're right. One listens the cue and then does whatever I need to be done after. And we're the consume one. Somebody has to tell that to consume the message exactly. So that is a primary difference between consumer and the listener. Caught? So this is very important. Like people often confuse like replay queue and the main queue. Every queue the replay queue is. Idle means replay queue. Always people focus on the main queue. Oh, even if you read any kind of stuff in the books, in the articles, they won't do the idea about the replay queue actually. How this message you know. Then for two-way communication, there are two channels. One is a main channel, one is a replay channel. Therefore, only for two-way communication. So that you need to understand. You have to get that one. Right? Then let me quickly give an example of publish consume also and move on to the next topic. I'm configuring one more. This one I'm giving path as publish consume. Publish consume. I'm configuring publish consume component. So this publish consume component, it's too like consume. It needs to be. Somebody has to tell them to. Somewhere. So it requires input, right? So it's waiting some. It's waiting for someone like a listener to ask either publish or consume. I'm sorry. Yeah, like you know the difference between the public consume and what do you call the input. Like you were saying earlier, oh, I'm sorry, the difference between listener and public consume, still public consume. Somebody has to tell it. Exactly. To go there, publish it or consume. Where listener and it listens to queue. Exactly. Got it. Only listener is the only component in the VM stack. It is a event source, right? Yeah, rest of all the three components are event processor. Somebody. That's right. Event processor. When you are configuring the first time the VM component, right? That time you need to create the queues. Create the queues. VMM2 are created queues. First component, next component onwards. You can use that configuration or you can create some more queues. That depends upon your requirement. See, I'm using this configuration called vmconfig. Vmfig is a configuration. Already has two queues. AM2. So if you want to, you can use this configuration to publish and consume, or you don't want to use this configuration. You want to create a new configuration. That's fine. Then what you can do is, instead of choosing this one, let's add one. And I'm adding edit inline. I'm adding one more queue. Something like I'm giving the name as VM2. See the configuration name as vmconfig1. You can use that also. You can customize as you want. Now I'm publishing to. You have to give a name. Let me see the configuration now. vmconfig is the one configuration. It has two queues. And VM2. And I have one more VM configuration. The name of that VM configuration is vmconfig1. Or you want to change the name, also vmconfig1 by default comes. And it has the queue called VM2. Right. Yeah. Now in your components, when you're publishing or consuming, you can choose using which configuration you're using. You're using vmconfig or vmconfig1. In the publish, I'm using the configuration of vmconfig. Right. In the consumer, I'm using the configuration of vmconfig. Yeah, also if I want to change, I can change the configuration. I can choose vmconfig1. So it depends upon our requirement. We can choose that one. What I find is your project may have multiple VM configurations. That's my intention. So I mean, like, maybe one that listens and the other one might be publish and consume. And maybe the other one is publish again. Also, I'm using the vmconfig one. Now I'm using vmconfig1. So what I'm doing is I'm publishing a message over here. And that message is consumed by your listener. And here what I'm doing is adding some kind of separate component. Some message I'm printing over here. Okay. This message, below, something, some process. So I'm here. We discussed about debug process, right? Yeah, the process. Yeah, debug process. Debug, how to debug the new application. The debug process. I think we touched it in the first couple of sessions where we can put a marker or something or break down something like that. Breakpoint, yeah, that's important. We need to see. We can see all what variables are created, what payload, what are the attributes. Are there? That's right. Any point of time you want to check, you can check. If something is going wrong, that's quite useful, that the debug is quite useful. I think it's some point here. Don't worry. Anytime, while discussing some complex examples also, I will show the debug. Okay. So now it is deployed. Now I want to use this component and publish something over here. So I'm going to Postman. What's the path I've used? I've used path code pubcon. I've got 4 time configurator 85. Right. So in the Postman 885, I'm using pubcon. And I'm posting some message over here. I'm posting the body. Some text message I'm posting. Text message as order. Order 1, 2, 3. I'm passing some random message. 2, 3. 1 set. Do you want to do like attributes? That payload. I don't want to listen. Some simple text message I want. Okay, I can tell you how dynamically we can capture and that also send us a response. And then use a different component. Set payload is not supporting that one. Started. I send this order. This order got processed, right? Okay, what's in the payload? I'm getting that response is okay. So this consumes something, right? So not actually. 1 second. No, now you're seeing my any point to the right. I don't know, I see. Any points to you. So, consume component. This public component is published component. What will you do? This will publish to the QA to the right. Yeah. What was the main queue? This is that because that message from our OK. And these are processes. What is happening is that we try to capture this one. So whatever message I post on the postman, right. So here multiple things you need to understand. So I post a stick message. And what is the user will do? Converts this to newly event message that discuss right. Attributes, payload and variables, right? So that is given to the publish component. But newly event is given for the published component. Newly events, but component. What is published on the component will do. We configured one queue. Right. That queue name is given as name1. It has the primary channel and replay channel. So right now it has newly event in hand. Published content will do is, it converts newly event to the VM message. Okay. So VM message. The VM message structure is standard messaging structure, like header and body. Header and. So whatever is there in the payload, the content is copied to the. By in the header default put something. But we don't have any control on the header. Whatever. We put some headers inside header section. And it's given to the your VMQ primary channel. The body goes to the primary channel. Then what's listed in the body, what is doing? Listen is always checking messages on the primary channel. Every few seconds. Information, the primary channel. Right. So once this component push the message in the primary channel, it becomes a message. It becomes a message given to the this now. What is this message? This message is VM message, right? Because this guy is converted to VM and put the VM message inside. The VM listener is capable of understanding the VM message. That's right. That's right. Then it converts that VM message to the Mule events. Payload section. Payload component. The payload component modifies the payload, whatever payload. You know existing payload. It modifies the payload. And what payload it puts is, I just defined that payload. So this order got. This is the payload. It puts that. You know it modifies this message. The logger will not do anything. But anyway, after that it's processing. The same Mule event is given back to your VM listener. So what VM listener will do is, it converts the response Mule event to VM message again. And that VM message is put in reply channel. So this publish confirm component is waiting for response in the reply channel. Once this listener places the message in the reply channel and pick up that message and send that to your postman. Therefore, the postman is able to see that message. Okay. So when we got a response back on and what is called the postman, it means it went through all of that and we get the result back from the publish consume channel. So like if you could go back to your postman now, is this how you configure right now? Like this one, the order get processed. This one, popcorn, I configured right now. So that's a second. That's the listener. Then that is the, which one is there? HTTP listener. So postman. So okay. So then that's the first one, right? Popcorn. So then went to the publish, consume. And then it published a message into the VM, right? Cool. And then the listener is the listener sub, the second subflow. The listener listens the queue, the VM Q1, and then set the payload. And then locked, right? Then after that, the publish, consume. Read the message from the reply queue exactly, and then publish it in the postman. You know it did very quick, though it was. We're not waiting much. It was very fast. Exactly. So can you, for just configuration wise, can you go one more time? The tabs, what's configure, what? The first component, vConference, is that right? This is to take the message from the postman. That's right. And they call it a pubcon. And it's pubcon. The path is pubcon. Path is going to be pubcon. And the host localhost 8285, yeah. So that is configuration of your HTTP. Next, I configure a component called publish consume component. Here I am referring the configuration as vmconfig1. This is a configuration referring, okay? See that vmconfig1. It has one queue. The queue name is vmq2. Right. I can look. I can refer this configuration. I know. You have a choice, yeah. But this one we're using VMQ2, right? So I'm from publish the payload. What period I'm coming from? The client. The same period I'm putting over here. That put the message in the VMQ2. Right? Oh, so I am here. And see if it is. See, one more configuration is timeout configuration. Timeout 5 seconds. Oh, what is timeout 5 seconds? Any idea, Adam? So, okay, I think yeah. So let me see if we can understand. So you will connect to the VMQ2. Put some message. If there is a problem or something like that, it's going to time out after 5 seconds. So it puts the message on the main queue and waits for the response on the replay queue. Okay, so this one, it doesn't wait much. It's 5 seconds. So within 5 seconds waiting to reply. Replay queue. Does it get answers in 5 seconds? Yeah. It's less than 5 seconds. Right. Yeah. Because the listener that message. And listen. There is much, processing. There is a user. Only set. Payload is there. Logger is there. It won't take that much time, right? Oh. But normally in real world work situation, you expand that time, right? If listener has so much confirmation, database lookup, and some other confirmation, okay, it's processing. Sometimes, therefore, we put that much of amount, whatever time is. Thank you. So now then, it published that into the VMQ2. Yeah, and then after that, the listener. The second one, VM listener. Yeah, kicks. Right. This one. So yeah. Exactly. In the primary channel. Yeah. So it grabs there. And then it creates a new payload. And the payload, you put it, something, get processed. It get logged. Then after that, the publish consume, gets the response back. Yeah. And from, okay. So, okay, whenever. Okay, we've set the payload. And when we set the payload, is that one. It sends the message back to the reply channel. No, just we are modifying the payload over here. It won't set just by changing the payload. Yeah, you change the payload. Yeah, then what after that? You want to log? Yeah, log it. We are just in the other. But if you put it, print something, you print it. Yeah, okay, that's fine. So then he went back to the message flow. This is good. And when it comes to message flow, then it puts stuff in the reply channel. Like and then public consume gets the. So I have a question then. Why don't you put a log or something? I have a question. So, okay. So this is right now. Right now we're not seeing. We're not seeing like I want to see what the reply channel has, what it applied. That says invisible actually. Okay, the contents of the shoes and channels in the VM. So what then? What we don't know is that the last message you got where it says that something get processed. We don't know if that it does come from on the second flow or that's coming from after publish, consume. We don't know. It's from second for itself, right? We did modifications in the second. Yeah, you don't know exactly idea we can do. But in this case we do. You know the payroll and sending back to reflect. Yeah, so you're right. You set the payload. You locked it and you know there is hard to see. Like from here, what you know, what information that the reply, what you call that, their approach and a queue has. I don't know, but hopefully we'll learn more later. But I think by now I understand the concept very good. At this point, I just want to understand how the message flows, on how the logic works, and later, I think, when we have a real-time situations. Yeah, no, I think we will see that and things under the hood exactly. Clear about this two-way main channel with the channel that's in right. Try to do something this example, then you'll get the idea about that. Okay, that's right? Okay. Next thing is try to see this always. You know any configuration you need on the graphical source code and try to see what code got generated in the source code mode. So see how this VM response is happening, how the head-up configuration. So this understanding is necessary going forward. Yeah, okay. And if you see every component right, every component has some unique id. It's a doc id is a unique id for the only component. It's automatically got created. Whenever you configure a component, a unique id got associated with that component. Okay, don't worry on that if you don't understand. Yeah, unique id for each level, component, listener, the unique id. Publish the unique logger, the unique id. What the unique id is, go to configuration, see for this listener. This doc for an id, right? This is unique. It got generated here 0.0325. This is id. Okay, this it identifies this component uniquely, whereas vmconfig, this is a unique id for him. mconfig1 is a unique id. Okay, so as of now, you didn't, and there's a significance of this uniqueness. Later, when you're comparing the M unit and other kind of stuff, then you understand the importance of the unique id. Just remember that each component has a unique associated with the component. Okay, so doc, what is the doc? Yeah, is that? What is that? What is the doc? The doc idea, doc right. What does it stand for? It's like a document identification number or second id. Yeah, okay? Okay, and finally do not forget to like, share and subscribe to our channel.